Hello everyone, my name is Wayne Jung, and today I will be explaining on the LNPs itself. What is LNPs, lipid nanoparticles, and also its mechanism in drug delivery. So firstly, what is lipid nanoparticles? So a brief description of it is a tiny fatty droplets that carry molecules into cells. So basically you can see the pictures right here. So the outer layer, the one that is in green color is um the fatty droplet, and the inside the interior is something that the LNPs will be carrying. And the use of it is very wide, and the most recent one that I believe everyone know about is in COVID-19 vaccines. So the vaccine that you use from like Pfizer is using this technique using LMPS to into our body to produce antibody, something that will help us prevent from COVID-19. And some advantage of it is that firstly, it protects payload. What does it mean by this? Is that you can see uh, when the inside is nucleic acid, or you can understand something like mRNA, for example, messenger RNA. So when it enter the cells, this interior is very fragile, so it needs to be protected by this outer layer, and the outer layer will prevent degradation by enzyme in the bloodstream, so it will help protect the interior. Secondly, its target specificity, which means that it functionalizes with ligands to precise delivery of this molecules MPS to the specific place, for example, to the lungs. Thirdly, its control release is that it officially released the payload, the mRNA, into inside cells, not like outside into the blood or something like that. And finally, its biocompatibility is that it designs to minimize the toxicity and be broken down naturally, so that we don't need to worry about where is it wandering around our body, where it enter the cells. Secondly, is about its mechanism. So I have mentioned earlier is that it deliver nucleic acid, right? For example, mRNA to desired place. So as you can see in this picture on the right, so when this enter the cells into the cell membrane, the outer layer will be degrade down, releasing the inside that will be translated into the protein that we need to prevent against certain disease or certain cancer or something like that. So basically its mechanism is very easy. So basically after it enter the cells through the cell membrane, the outer layer will be gone, the inside will be released and will be translated to our necessary protein. And lastly, since this is an innovative technology that is new today, not something that we discovered in the 80 or 90 something, so there's still a lot of area to improve. For example, we can future work can be on minimize the toxicity of LNPS. What does it mean like this is that because this lipid can disrupt cell membrane or cause inflammatory response, for example, like causing you feel itchy or feeling hurtful or swelling, something like that. It was some example inflammatory response. So it can be hurtful for a human. Secondly, its off-target effects is that sometimes this can be um accumulate at other parts of the body. For example, if we want it to be in the lungs, it can be accumulated, for example, in the kidney or in the other parts that we don't want it to be. And thirdly, is immune activation is basically something I mentioned earlier that it can trigger inflammation, which is will be bad for human. And lastly, is production challenge. It's because LNPs need to store at a low temperature, and also it's kind of expensive when using LNPs. So so it's kind of hard to be produce it in mass amount, so it's still a little bit on challenge for us right now. So that's all on LPS. Thank you for listening.